Hello, good morning students. I am Preena Dayani and I am your chemistry teachers. I hope your preparation for the exams is going well. So, in the chapter of atoms and molecules, we are about to start our new topic, that is mole concept. If we want to count a certain quantity, we always need a unit to define that. Suppose if I have to count the number of pencils or number of chalks, I will assume the quantity will be in dozen. Suppose I have to count the quantity of a solid, it may be in kilogram or gram. Suppose I have to measure liquid, it must be in liter or kiloliter. Similarly, if we have to count atom, molecules and ions, we will count it in the quantity called mole. Suppose if I have to count pencils, we may say 12 pencils. So, we may call it 1 dozen. Suppose I have to count the books. If I have 144 books, I can call it 1 gross. So, this is actually the units for counting something. We always need a unit to count something. So, similarly in our chemistry, if we want to calculate atoms, ions and molecules, we also need to define a unit. So, this unit is known as mole. So, mole here is actually a word that is come from Latin language. And this word basically means heap or a pile. So, if we want to calculate the number of atoms, ions and molecules in a compound, we will define it in a unit that is called mole. It will count number of atoms, ions and molecules. Now, the term mole has been first used by a scientist named Oswald in 1896. This term mole has been basically used by a chemist known as Oswald in 1896. So, it means mole is a unit to count the number of atom, ion or molecule, and 1 mole of any substance will give us the number of atoms, it may be number of ions or it may be number of molecules. So, now we will learn more about mole. 1 mole will be equal to 6.02 into 10 raised to the power 23 atoms. So, it is standardized to calculate 1 mole as 6.02 into 10 raised to the power 23 atoms. It means here this number is always remain constant and we may call this number as a Avogadro number. Avogadro's number, and it is denoted by Na. This quantity is fixed. This is used in solving the major numerical problems related to the mole concept. Now, we will learn how mole concept quantities can be calculated for different atoms, ions and molecules. Firstly, we have a unit mole here. If we want to calculate the mole in terms of particles and in terms of, firstly we will calculate in terms of particle. Secondly, we will calculate in terms of atomic weight or mass of a substance. So, mole is basically divided into 2 categories. Firstly, in terms of particle and second in terms of atomic weight. So firstly, I will define here in terms of particle. In terms of particle, we have three categories here, and similarly, in terms of atomic weight, again we have three quantities here. First, 1 mole of a substance will tell us about the number of atoms. And it will be numerically equal to 6.02 into 10 raised to the power 23 atoms. Secondly, it will tell us about the number of ions. Again, we have 1 mole equal to number of ions, and number of ions will be numerically equal to 6.02 into 10 raised to the power 23. Third category, we have about the number of molecules. And number of molecules will be numerically equal to again 6.02 into 10 raised to the power 23. So, in terms of particle, we have defined the mole concept into three categories, that is about number of atoms, number of ions and number of molecules. So, this is basically defined on the basis of number of particles. Now, we are on our second category. Our second category is in terms of weight or mass. Firstly, it is defined in first category, that is 1 mole of a substance will be equal to gram atomic weight will be the GAM of a substance. Second, it may be defined in terms of weight of ions. Third category we will have in terms of mass of molecules. And the mass of molecules will be gram molecular mass, that will be equal to GMM. So, what actually the 1 mole of a substance represent? Here we have standardized it, that is called 1 mole. The 1 mole of a substance in case of particle will be equal to 6.02 into 10 raised to the power 23 atoms. Here 6.02 into 10 raised to the power 23 atoms is the standardized, that is called Avogadro's number. In terms of ion, it will represent the similar data, and in terms of molecule, again we have 6.02 into 10 raised to the power 23 molecules. Now, mole will be defined in terms of weight. If we are considering about atom, it will be equal to GAM. If we are considering about ions, it will be equal to the weight of the ions, and if we talk about the molecules, it will be equal to the GMM of a substance. So, this is whole picture about the mole concept, which is used to solve the numerical problems over here. If someone wants to copy it, please copy it now. Now, for solving our numerical problems, we will consider some important formulas regarding this. So, what actually the 1 mole of a substance is? The 1 mole of a substance will be equal to Avogadro's number, and Avogadro number will be equal to 6.02 into 10 raised to the power 23, and it is denoted as Na. Now we will learn about the mole concept in terms of atomic mass. So our second topic is mole in terms of mass. So mole in terms of atomic mass means 1 mole of a substance will be equal to the atomic mass of that particular element. So if we count about 1 mole will be equal to atomic mass of that element. Here we have an example. Suppose we have 1 mole of O2 atoms. We know that atomic number for oxygen will be 16. If we are concerned about O2 atoms, the atomic number will be 32, that is 2 multiplied by 16. So we have 2 into 16, that is equal to 32. So in 32 gram of an O2 atoms, we will have 6.02 into 10 raised to the power 23 atoms. So it is all about the mole in terms of atomic mass. It will be equal to the atomic mass of that particular element. Now we have mole in terms of molecules. If we talk about mole in terms of molecule, what will be difference between the atom or the molecule? The compounds are considered in this case. So here 1 mole of a substance is basically equal to molecular weight of that substance. So if we consider an example of water, suppose we have H2O, we know that we have atomic mass of hydrogen is 1, so it will be 2 into 1 plus oxygen, we have a mass 16, so mass of water will be 18 gram. So in 18 gram of water, we have 6.02 into 10 raised to the power 23 atoms, so it is 1 mole and it will be defined in terms of molecules. So 18 gram of water contain 6.02 into 10 raised to the power 23 atoms, and it is all about the mole concept in terms of molecule. So we have discussed mole in terms of atomic mass, and second category we have the mole in terms of molecules. Now we have the mole in terms of gases. So we have our third topic, that is moles in terms of gases. So if we want to count the moles of a certain gaseous atom, we have to consider the volume of that case, and this volume will be standardized at the condition of standard temperature and pressure, that is temperature will be 273 Kelvin and the pressure must be 1 atmospheric pressure, and the volume of gas at that quantity will be 22.4 liters. So, if I talk about gases, we will not calculate the weight of the gases. In spite of that, we are concerned about the volume of gas. So, the volume of gas will be calculated at STP. STP here means standard temperature and pressure. Standard temperature and pressure. So, temperature will be considered a standard quantity here and pressure will also be considered as a standard quantity here. We have a fixed temperature here. The temperature will remain 273 Kelvin and the pressure we are going to take will be 1 atmospheric pressure. So, these are the standard conditions for temperature and pressure, and that STP, the volume of any gas will be calculated as 22.4 liters. So, this is the standard. Now, we are talking about the number of moles for gases. So, volume of 22.5 liters will be equal to 6.02 into 10 raised to the power 23 atoms. So, if we are talking about 1 mole of gas, it will be at the 22.4 liters standardized volume, and this will be calculated as 6.02 into 10 raised to the power 23 atoms. So, it is about the mole concept in terms of volume. So, we have discussed the mole concept in terms of atomic weight. We have calculated it in terms of molecular weight, and third category we have the mole concept in terms of gases. Now, this topic is clear with the help of some examples. I am writing certain examples here. Suppose we have our first problem, that is calculate number of moles in, we have our first part 52 gram of helium, second 60 gram of calcium. Suppose we have to calculate the number of moles among these two quantities. So, in the question we have to calculate the number of moles, and the quantity we had given here is the atomic, it is the total weight of both the elements. So, we will calculate the number of moles over here. So, in our first part we will calculate the number of moles. So, the formula for calculating the number of moles will be small m upon capital M. Small m will be the capital M upon small m. Capital M will be the molecular weight of that substance. Atomic weight of the substance. Now, number of moles can be calculated as we know, in helium gas, its atomic number is 2 and we have atomic mass of 4 over here. So we have to calculate the number of moles in 52 gram of helium. So we will take 52 in the numerator, we will take 4 in the denominator. If we are going to solve this equation, we will get 13. So the number of moles present will be 13. So 13 will be equal to number of moles. So this is a formula for calculating the number of moles. Now we are on our second problem. We have to calculate the number of moles in calcium. Similarly, we have our second part. We want to calculate number of moles in calcium. So number of moles will again equal to capital M upon small m. We know that for calcium we have a atomic number 20, and for it we have a atomic mass, that is double of it, that will be equal to 40. So we will write 60 upon 40. If we are going to solve this equation, we will get 3 by 2 here. So the number of moles will be present in 60 gram of calcium will be 3 by 2 mole, that is equal to 1.5 mole. So here we have discussed about the calculation of number of moles. Now we will consider our second problem. We will talk about our second problem. Suppose we have to calculate weight of 0.5 mole of O2 gas. So we have to calculate the 0.5 mole of O2 gas weight here. So in this situation we had provided with the number of moles. So we had given a number of moles that will be equal to 0.5. Now we have to calculate the weight of the O2 gas. The weight of the O2 gas will be calculated as, we have a formula for calculating the number of moles, that will be equal to capital M upon small m. For O2 we will calculate the atomic weight here. We know for a single atom of oxygen the atomic weight will be equal to 16 gram, but we are talking about O2 here, so we will multiply it by 2 and we will get here 32 gram. So number of moles we have provided here is 0.5. The value of atomic weight we have to calculate here and we will divide it by 32. So on cross multiplying we will get 0.5 into 32. If we are going to solve this equation, we will get 16 gram. So we will calculate the weight of O2 molecules as 16 gram, which is the value of small m, and capital M we have put here equal to, capital M is calculated here is 16 gram and small m we have put here is 32. So it is all about the mole concept we have studied today. This topic is over here, and for the further problems we will discuss about it in our next lecture. Thank you so much.